version 6, production to IP version 6. When we use the internet for any activity, be it email, data transmission, web browsing, downloading files, image or video, or any other service or applications, communications between different networks, elements, and our own computer, laptop, or smartphone uses a protocol. The IP or Internet Protocol is which specify the technical format of packet and the addressing schema for computers to communicate over the network. Internet Protocol version 6 is the most recent version of the IP. The communication protocol that provides an identification and a location system for computers on networks and route traffic across the internet. In order to connect any device to internet, it is necessary to provide an IP address to the devices. The first version of Internet Protocol publicly used was IP version 4, Internet Protocol version 4. This protocol was created by the Defense Advanced Research Project Agency, or DARPA. DARPA is an agency of the U.S. Department of Defense responsible for the development of emerging technologies, mainly for military applications, created in 1958. IP or Internet Protocol version 4 includes an addressing system that uses numerical identifiers consisting of 32 bits. The use of address with a length of 32 bits limits the total number of possible addresses to a number of approximately 4.3 billion addresses for devices connected to internet around the world. The number of devices connected to the internet will be soon bigger than the number of addresses provided by Internet Protocol version 4. For this reason, and in anticipation of the situation, the agency responsible for standardization of Internet Protocol, the Internet Engineering Task Force (IETF), has been working in new IP version from 1998. The Internet Protocol version 6, the successor protocol that is intended to replace IP version 4, was first formally described in Internet Standard Documents. IP version 6 uses 128 bits address format along 2128 or approximately 3.41038 addresses, or approximately 8,028 times as many as IP version 4. While increasing the pool of addresses is one of the most important benefits of IP version 6, there are other important technological changes in IP version 6 that will improve the IP protocol, either administrations, better multicast routing, and a simple header format, and a more efficiency routing, built-in authentication, and privacy support among the IP version 6 will coexist with the older IP version 4 for some time. Others. The deployment of IP version 6 will be made gradually in an orderly coexistence with IP version 4. Client devices, network equipment, applications, content, and services are to be adapted to the new Internet Protocol version IP version 6. Moreover, the transition from IPv4 to IPv6 will establish a common set of standards between a company's education system around the world. IPv6 addresses are represented as 8 groups of 4 hexadecimal digits. These groups are separated by colons, but methods to appropriate this full notation exist. Thank you. This is IP version 6 addresses are represented as 8 groups of 4 hexadecimal digits. These groups are separated by colons, but methods to abbreviate this full notation exist. Internet Protocol version 6 header format is shown as below. The version is 4-bit Internet Protocol versions number as equals to 6. The traffic class 8-bit traffic class field, flow level 20 bits flow levels, payload length 16 bits unsigned integers, length of the IPv6 payload, That means the rest of the packet following this IP version 6 header in octets. The next header. 8-bit selectors identify the type of header immediately following the IP version 6 header uses the same value as IP version 4 protocol fields. Hop limits. 8-bit unsigned integers decremented by 1 by each node that forwards the packet. The packet is discarded if hop limit is discriminated to 0. Source address 128 bits address of the originator of the packet. Destination address the address 128 bit address of the intended recipient of the packet, possibly not the ultimate recipient if routing headers is presented. The newer version introduced with the IP version 6 protocol are basically the following: a new header format, an efficient and hierarchy address and routing infrastructures, much larger address space and stateless and both firewall address configurations, IP security, extensible, a better quality of service, support and a new protocol of neighbor node interactions. The IP version 6 protocol has solved some of the security problems found in IP version 4 networks by adding the IP security as a mandatory. As a result, IP version 6 is more efficient. IP security enhances the original IP protocols by providing authenticity, integrity, confidentiality, and access control to each IP packet through the use of two protocols, AH or authentication headers and ASP encapsulating security payload. Moreover, the expansion of the number of bits in the address field to 128 bits offered by IP version 6 creates a significant barrier for attackers wanting to conduct comprehensive port scanning. On the other hand, it is possible to bind public signatures key to an IP version 6 addresses, cryptographical generated addresses. IP version 6 offers also improvements on mobility security, despite that the mobile IP internet protocol is available in both IP version 4 and IP version 6. In IP version 6, it was built into the protocol instead of being added as a new function in IP version 4. This means that any IP version 6 node can use mobile IP pause as required. Mobile IP version 6 uses two extension headline, a routing header for registrations, and headline target to data delivery between mobile nodes and their corresponding fixed nodes. This is all. Thank you.